students. Welcome to another live math class. And today we're going to be looking at plotting linear and quadratic graphs. Now, this is a topic that we have done several times before. As you know, practice makes perfect. So for the persons who are just being exposed to graph, you're still not sure what to do, we're going to go over them again, okay? So the first thing we're going to do is learn how to set up our tables for the linear graph. And then from there, we're going to plot our linear graphs. Remember that the linear graph will give you a straight line, and that's where we get the word linear from, right? From line. How you know a linear graph, or how you know a linear function? The highest order or the highest power of the variable, usually an x, the highest power will be 1. So that means you're only going to see x, not x squared, not x cubed. So for example, y equals x. That's a simple linear graph. Y equals negative x, y equals 2x, y equals negative 5x, y equals 3x plus 9, anything like that, right? That will give you a line. So we're going to do some simple lines, and then we're going to go to the quadratics and see how we solve those. So it's plotting linear and quadratic graphs. Now, normally, you're given the function or the equation. So for example, y equals 3x plus 5, right? And you're also usually given a domain. So the domain tells you where to start your x values and where to stop. So we read this from the middle. So we read it from here. X is greater than or equal to. So normally you'd read this sign as less than or equal to, but because we're reading from the middle this way, so from the x that way and from the x that way, so we're saying x is greater than or equal to negative 2 and less than or equal to 4. So the x values or the domain values will start at negative 2 and end at 4. Because it's a straight line, in order to draw a straight line, you really just need 2 points. And then you connect the 2 points and you get your line. So we are going to use the 2 endpoints, and then we're just going to throw 0 in there just to see what's happening at the origin. But we don't really have to. We just like to see what's happening at the origin, right? Now, for this function, for the linear function, there are a number of things you can tell just by looking at the function. Just looking at the equation, you can tell the gradient of the line. So the gradient of the line is this number here that is in front of the x. The coefficient of the x term tells you the gradient. The number at the end of the line is what we call the y-intercept, and that tells you where the line will cross the y-axis. All right, so that's two things you can tell. You can also tell which way the line is oriented. So it's a positive, the gradient is positive, it will be oriented that way, right, to the right. If it was negative, it will be oriented this way. So there are a number of things we can tell. So let us set up our table. And so we're going to put our x values. So -2 to 4. We only need the endpoints. So -2, 0, 4. And now we're going to put in the terms of the function. So we have 3x and we have +5. And then we are going to get our y values. So we're going to multiply each of the x values by 3 because it said 3 times x. So 3 times -2, that's -6. 3 times 0 is 0, and 3 times 4, that's a +12. And we're going to add 5 to each of those. So we can put +5. So -6 plus 5 is -1. 0 plus 5 is 5. 12 plus 5 is 17. So now we can write our coordinate pairs that we're going to plot. So our coordinate pairs would be -2 to -1. So we can write it here. So -2 on the x, -1 on the y. Our next pair is 0 to 5. So 0 to 5. And 4 to 17. So that's 4, 17. So these are the points we're going to plot on our coordinate plane or our graph. So looking at the values, our x values from -2 to 4, and our y values from -1 to 17. So we're dealing with fairly small numbers, relatively small numbers. So we're going to draw our axes. So that's my y-axis. I just have a -1, so I don't really need much of my negative y-axis. So I'm going to draw the x-axis further down, put my origin dead center. So I need 4 on the positive x. So 1, 2, 3, 4. And so that would be -1, -2, -3, -4. I need to go up to 17 on my y-axis. So I can go up by 5. So 5, 10, 15, 20, and that would be -5. So to draw my points now, so it's -2 on the x to -1 on the y. So I move across -2 on the x and go down. So -1 would be, this is -5. So -1 would be around there. So -2 on the x down to -1 would be about there. 0 on the x to 5 on the y. So that's 0 on my x. I'm not moving on the x, it's still 0. And I'm going up to 5. and 4 on the x, 17 on the y. So 4 on the x up to 17. What I'm going to do next is to join the points. So I'm going to, if I were doing this on graph paper, I would take the ruler and connect these 3 points, right? Connect. So here are the 3 points I would. So since I'm doing this on, I don't have a ruler here, I'm doing it freehand. So I'm gonna try my best to make it straight and keep it. All right, that's the best I can do. So you would take your ruler and connect those 3 points and you would get a straight line. And then what you're going to do now is to write the equation on the line. So you would write on the line y equals 3x plus 5. And that is your linear graph. So we're going to do one now with a negative coefficient. We're going to do a linear graph with a negative coefficient for the x term. So in this case, the x was positive. We have a 3x. I'm going to now make the x negative. So you notice with this this line here with the positive 3x is oriented to the right. Now we're going to see what happens if we make the x term negative. So let's say we have y is equal to negative 4x plus 1. For the domain, x is greater than or equal to negative 3 and less than or equal to positive 3. So that's our domain. And we're going to rule up, oh my gosh. I can do better than that. We're going to rule up our table. So we have our x values, which is from negative 3 to positive 3. And we're going to put 0 in between. The function says we're to multiply the x values by negative 4. So we have negative 4x. And then we're going to add 1. So plus 1. So negative 4 times negative 3. That's going to give a positive 12. Okay, so negative 4 times negative 3 is positive 12. Negative 4 times 0 is 0, and negative 4 times positive 3 is negative 12. And we're going to add 1 to everything. So our y values would be 12 plus 1, which is 13, 0 plus 1, which is 1, and negative 12 plus 1, which is negative 11. So our coordinate pairs would be negative 3 to 13, 0 to 1, and 3 to negative 11. All right, so we're going to plot these points now on our graph. So I'm going to put my line in the middle this time because we have a positive 13, negative 11. Pretty much same distance from the center on the positive and negative y-axis. On my x-axis, I need to go up to 3. So I have 1, I have 2, 3, negative 1, negative 2, negative 3. And to get 11, so I can go by 5. So 5, 10, 15, and negative 5, negative 10, negative 15. So to plot the points, so negative 3 to positive 13. Negative 3 on the x, and we go up to positive 13. That's about there, right? Negative 3 to positive 13. 0 to 1. So 0 up to positive 1. And 3 down to negative 11. So 3 on the x, down. So negative 10 is here, negative 11 is about there. All right. So now to connect those 3 points, so you notice, so you take your ruler and keep it straight and connect those lines. So you notice the line is oriented this time to the left. So that way, the other line was oriented this way. So the gradient is negative 4. It's negative, so the line is oriented to the left. The y-intercept is 1, so that means the line will cross the y-axis at 1. All right. For the newcomers, give me some feedback. Let me know if you understand what's happening, or if there's any point that you want me to go over. So what we're going to do now is we're going to plot some quadratic graphs. For the quadratic, because it is a quadratic, meaning the order of the x, the order of the variable, the highest order is 2. So we're going to see an x square. You can also have an x, but you must have an x square as well, or just an x square. You can have a constant term as well, as you don't have to. Because it's going to give you a curve, the quadratic gives you a curve, right? And we call that curve a parabola. Because it's a curve, we can't just plot 3 points, because we need all the little points that's going around the curve so we can connect the curve properly, smoothly. So we're going to take all the points on the domain that we're given. If we're told it's from negative 3 to 3, we're going to list out everything from negative 3 to 3. So that would be negative 3, negative 2, negative 1, 0, 1, 2, 3, all of them. And we don't use a ruler when we are connecting the points for the quadratic. We just use our free hand and connect the points. So let's say we are given a simple quadratic. Y equals x squared plus 2x minus 4. and the domain -3 to 3. So we have to plug in all those points. So the first thing we do is we write our x, so our x values. So x from -3 to 3, all the points. -3, -2, -1, 0, 1, 2, 3. So we're going to have x squared, 2x, positive 2x, minus 4. And we're going to get our y values. So the first thing we do is to square our x values. So remember, when you're squaring a number, you're multiplying it by itself. So if we have negative numbers being multiplied by themselves, so -3 times -3, the answer is going to be a +9. And -2 times -2, that will give a +4. -1 times -1, +1. All right, so when we square all these, this is what we get. And after we square them, it says we're to go back to the x's. Now the x squares go back to the x's, these, the x's, and multiply them by 2. So it's 2 times -3, which is -6. 2 times -2 is -4. 2 times -1, -2. 2 times 0 is 0. 2 times 1 is +2. 2 times 2 is 4. And 2 times 3 is 6. Then we're to take 4. So we're going to subtract 4. All across the board, just write -4. So now we're going to combine our terms, and we always start wherever the function starts. So this function started at x squared, okay? So we're starting at this row. So we're starting at the 9. So it's 9 minus 6, which is 3, minus 4, which is -1. 4 minus 4 is 0, minus 4 is -4. 1 minus 2 is -1, minus 4 is -5. 0 minus 4 is -4. 1 plus 2 is 3, minus 4 is -1. And 4 plus 4, 8, minus 4 is 4. 9 and 6, 15, minus 4 is 11. So our coordinate pairs, let's write our coordinate pairs. So it would be -3 to -1. -2 to -4. -1 to -5. Zero to -4. 1 to -1. 2 to 4. 3 to 11. All right. So let's plot those. So when we look, we realize that we have mainly negative values for the y, and they are small We have a relatively larger x value. So I think we would need a bigger, a relatively larger positive y value, which is the 11. So we need a bigger space on the positive axis. So we can draw our x-axis here. For the x values is 1 to 3. So 1, 2, 3, and same over here, -1, -2, -3. We have some small negative numbers here down to -5. So we can just put -5 and we can estimate for the others. This needs to go up to 11. So I can go by 5 also, 5, 10, 15, and I'll estimate 11. So it's -3 to -1. Put in our origin, which is 0, 0. So -3 and -1 would be about there. So where that meets -3. So let's put it at about there. -2 to -4. So -2 down to -4. -1 to -5. So -1 on the x down to -5 there. 0 to -4. So 0 down to -4. 1 on the x to -1. So 1 on the x down to -1. So that's roughly there. 2 to 4. So +2 on the x, +4 on the y. And 3 to 11. So +3 up to 11 is about there. I'm estimating, right? So on your graph paper, you would have it accurate. Once you follow your scale properly, you won't have to estimate. So remember, it's a curve. I'm not going to use the ruler. I'm going to take my free hand and connect. And that's my parabola or part thereof. Now I'm going to, as usual, I'm going to write the function. So that would be y is equal to x squared plus 2x minus 4. And that is our quadratic. Right, so the quadratic gives us a curve, not a straight line. And remember the order of the quadratic, the highest order of the quadratic function is a square. So you can have an x, can have 6x squared minus 5x, right? So you can have an x, but you must have the x squared. The constant term at the end, the whole number at the end, it's you can have it, or as well as it might be 0, and then you don't see any constant term there, right? The constant term in the quadratic also tells you where the curve will cut the y-axis. So if you don't see a number at the end, it will indicate that the curve would cut the y-axis at 0, 0. So it will center the parabola about the origin. Let's try another quadratic. This time we're going to make our x squared coefficient negative. And we're not going to put any constant term. So let's say we have -3 x squared plus 6x. All right, so let's try it. Sorry, I didn't put my y equal. So y equals, and my negative there is too big. So negative 3x squared plus 6x for, let's say, negative 4. So x is greater than or equal to negative 4, less than or equal to 3. And we know we're going to need a lot of space because we're using up all the points on the domain. So we start with our x squared. So we square the x. And then we're going to have minus 3 times the x squared. So minus 3x squared plus 6x. And combining those will give us our y value so we can get our coordinate pairs. So the domain says we're to start at negative 4 and go all the way up to 3. So we have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. So we're going to, oh, I did the wrong thing. I'm supposed to have, I did the wrong thing. I'm to have x alone there, and then x squared, and then 3x. All right, so that's x. We're going to square our x's, then we're going to multiply them by negative 3x, and then we're going to have 6x, and then our y values, right? So squaring each of these, negative 4 squared, so that's negative 4 times negative 4, which is a positive 16. Negative 3 times negative 3, positive 9. Negative 2 squared is 4. Negative 1 squared is 1. And 1 again, and 4 and 9. Now we're going to, so these x squares, we're going to multiply them by negative 3. So negative 3 times positive 16 is negative 48. Negative 3 times positive 9 is negative 27. Negative 3 times positive 4 is negative 12. Negative 3 times 1 is negative 3. 0. Negative 3 times 1 is negative 3. Times 4 is negative 12. And times 9 is negative 27. And now we're going to multiply the x's, so not the x squared, x's, these, multiply them by 6. So 6 times negative 4, so that's negative 24. 6 times negative 3 is negative 18. 6 times 4, 6 times negative 2 is negative 12. 6 times negative 1 is negative 6. 6 times 0 is 0. 6 times 1 is 6. 6 2 is 12. And 6 3 is 18. So now we're going to combine these, but where do we start? Do we start in this row, this row? Go back to your function. Go back to your equation and see the first term. The first term is negative 3x squared. So we start in the negative 3x squared, this row. This is where we start, not here. So it's negative 48 minus 24, and I'm going to give a negative 72. So we're getting some bigger numbers here, negative 72. Negative 27 minus 18 and that's negative 45. Negative 12 minus 12 is negative 24. Negative 3 minus 6, negative 9. We have 0. Negative 3 plus 6 is positive 3. Negative 12 plus 12 is 0. And negative 27 plus 18, that's negative 15. All right, so let's see how this graph is going. So coming from the negatives up, going to 0 to 3 to 0. All right, so it's going to be that way. That's how it's doing. So we have some bigger digits here, most of which are negative. So we only have one positive value, and it's 3, so not far from the axis. So we're going to put most of our y-axis below the x-axis. We only need a 3 up there. We need this to be 72. So we're going to do a lot of estimating here on the board. On your graph paper, you could work out your scale so you don't have to estimate. I'm going to go up by 10. Since I needed my limited space here to go down to 72, right? Negative 72. So I'm going to have negative 10, negative 20, negative 30, negative 40, negative 50, negative 60, negative 70. Then I can estimate negative 72. And on the x, so pretty much 1, 2, 3, 4. All right, so let's plot. We're not going to write out our coordinate pairs now because we have limited space. So let's just read them off. So it's negative 4 to negative 72, right? So negative 4 down to negative 72, that's about there. And negative 3 to negative 45. So negative 3 on the x, down to halfway between the 40 and the 50. All right, so Imani is saying, okay, so the negative 27 plus 18. Okay, so that should be negative 9. Thanks, Imani. So this one should be negative 9. All right. Okay, so where are we now? So negative 2 to negative 24. So negative 2 on the x, down to almost halfway between the 20 and the 30. So that should be about there. Negative 1 to negative 9. So negative 1 on the x, down to negative 9, almost touching the 10. 0 to 0. So remember I told you, if it doesn't have a constant term, or in other words, the constant term is 0, it's going to anchor about the origin, right? And now we have 1 to 3. So 1 up to 3, 2 to 0, so back down to 0, and 3 to negative 9. So 3, that down to negative 9. All right, so let's connect our dots. Remember, no ruler. It's quadratic. We don't need a ruler. We use our free hand, and we just try and be as careful as we can. And we try and get it. That did not go through, but it's supposed to go through. let me redeem myself. So it did not go through. Let me see if I can do any better. So this, take my time, let me take my own sweet time. Okay, that's a little better. You won't have this problem, you know, because you're using your graph paper. It has been, you have your grade, it rule up for you already, so you're good. I'm using this limited space and this mouse that don't want to cooperate with me. So now I'm writing my function y equals negative 3x squared. And it's plus 6x. And that's it. Negative 3x squared plus 6x. Yeah. Yeah, so that's that. So you notice that for when the coefficient of the x squared term was positive, in this case positive 1, the parabola was oriented up, right? Up, which some people call a smiley face or a tick, depending on what the domain is, how wide we got the curve. And you notice when it's negative, why isn't my mouse moving? When it's negative, it was oriented that way, right? My mouse isn't turning the slides, so I can't show you again. All right, but that's how it's oriented. So that the positive will be oriented that way, negative that way. Or even if it's a part of it, you get it. Because depending on the domain, sometimes you won't get the whole complete parabola, depending on where you stop on the domain, right? But if it is positive, it will be like this, or any part thereof. And the negative would be like that. So we can stop there for the graphing linear and quadratics. Hopefully this is enough, to get you going, and then you can always watch these videos again to remind yourself. Okay, so rewatch the videos. If you're not sure of anything, go back to these videos on the channel, or go to the graph playlist on the channel and refresh yourself on how to plot graphs. All right, so the next class we'll do some more plotting graphs, but maybe not to go over these linear and quadratic. I think you should have it down pat, because we've been doing several videos just on this. So we'll look at other aspects of plotting graphs.